Hey everyone. Okay, let's have a look at chapter 13. We're just going to be touching on this chapter just so that you have an understanding of what an annuity due is, both for present value and for future value. And the only difference between the annuities that we've been looking at and an annuity due is that instead of waiting until the end of the first month or the end of the first 2 weeks or whenever the payments are due, we're having a payment due right at the beginning. So say you lease a car, and that day before you drive the car off the lot, your first payment is due. Okay, that's referred to as an annuity due. All right, let's have a look. Okay, so again, annuities due are annuities where the payments occur at the beginning of each period. Therefore, the payments in an annuity due earn interest for one extra payment interval. Okay, so think of it this way. If you decide to make payments at the beginning, then right at the beginning, a payment is made and there's money in there earning interest. Whereas an ordinary annuity, if the payment is made at the end of the term, then it doesn't have a chance to earn interest. Okay. So an annuity due is a series of equal payments made at regular intervals where the first payment occurs right away. So as you can see here, at time 0, a payment is made. And there's no payment made at the end. So as before, the time between successive payments is called the payment interval. The time from the beginning of the first payment interval to the end of the last interval is the term of the annuity. Okay, if you remember this flow chart, let's have a look. Okay, so are the payments at the end of the payment interval? For the chapters we've been covering so far, the answer has been yes. But this case, the answer is no. Are the payments and compounding intervals equal? If they're yes, okay, so your payments per period and when it's compounded. So if they're both monthly, if they're both quarterly, if they're both semi-annual, then it's a simple annuity due. But if they're different, if the payments are made monthly, but it's only being compounded semi-annually, then it's a general annuity due. Okay, so it follows the same pattern as previous, where it's either an ordinary simple annuity or an ordinary general annuity. Now it's a simple annuity due and a general annuity due. So let's look at future value. So future value due. So the future value of an annuity due is the sum of future values of all the payments calculated at the end of the term. The term ends at the end of the last interval, which is not where the final payment occurs. Okay, so the final payment occurs at the beginning of the last period. So we must take that final period into account when locating the end of the term. So if it's being figured out that it's a 10-year term and the final payment is made at the beginning of the 10th year, you must still consider it 10 full years. Okay, so if the future value due is 1 period later than the future value for an ordinary annuity, we can simply move the future value amount forward in time 1 period to get the future value due. In other words, we can multiply our future value formula if we were using the formulas. But again, I'd like you to have a look at the formula, but we will be using our financial calculator to do this calculation, which is going to make it that much easier. Okay, so in other words, we can multiply our future value formula for an ordinary annuity by 1 plus the interest rate to get the future value due formula. Okay, so if it was just future value of an ordinary annuity, this would be your formula. But what makes it future value due is multiplying the solution by 1 plus the interest rate. Okay, so let's look at an example. Rob deposits $200 at the beginning of each month into a savings account, earning 6% compounded monthly. Okay, so they're both monthly. How much will be in the account after 10 years? Okay, so we've got our information. We've got our payment of $200. We've got our interest rate of 6%, and we have our N of 10 times 12 to give us 120. Okay. So if we were to use the formula, we'd use the normal formula for the future value and then multiply it by 1 plus I. Okay, and using the formula, you're getting $32,939.75. Let's look at the calculator. So what we're going to do for the calculator is we're going to move it into a new function. Okay. Then the information that we put in there related to the calculation, it knows that it's a beginning mode or a future value due that we need to calculate. So what you need to do is take your calculator and hit second, okay, BGN, and the BGN is behind the PMT button. So you want second BGN, okay, second set, second quit. And now if you look at your screen, it's going to show 0 point and then your decimal places that you have set. But above that, it has a small BGN. So that means that it's in the beginning mode, which means that your payments are due at the beginning, which is what future value due means. Okay, so now that you've got it set in beginning mode, we're going to try this calculation. So we have 6 IY, and we need second PY. We want to change that to 12 from whatever it was. So 12, enter. You can arrow down. You can see your CY is the same as your PY. Okay, so now we need second quit to come back up to the main level. We know N is 120, 120 N. We need 0, present value, 200. Remember, it's payments going out, so you want to hit your plus minus button to turn it into a negative. So on your screen, you've got minus 200, and you want PMT. And then we're going to go compute future value. And the future value is exactly the same amount as what it was in the calculation on the previous screen. Future value is $32,939.75. Okay. I'm going to move past this example and move to future value, to present value. Okay, So present value of an annuity due. The present value of an annuity due is the sum of the present values, all the payments calculated at the beginning of the term. So the term starts at the beginning of the first interval, which is also where the first payment occurs. Okay, we can make the same adjustment we did with the future value due formula to create the formula for the present value due. Okay, so again, if we were using the calculations, you've got your regular calculation for present value, and then to turn it into a present value due, we multiply that whole thing by 1 plus I, or your interest rate. Okay. So the example given here for present value due, calculate the present value of a 10-year ordinary annuity with quarterly payments of $500 using a rate of 8% compounded quarterly. Okay. So we have a payment of $500, we have our interest rate of 8%, we have our N of 10 multiplied by 4 because it's compounded quarterly. And if you use the formula given, then you're going to come up with $13,951.29. So let's try it with the calculator. So again, we need it in the beginning mode, but if you haven't changed it back, then it's still in the beginning mode from when we did the future value. Okay, so your display should have the BGN still on the screen. Sorry about that. Okay, so let's look. Okay, so on mine, where I have on my phone, it does not show the BGN on my screen again, or still. So I want to put it there. So I want second, the payment button, because that is the BGN. Second, set, which is above the enter, and that's showing BGN. Second, quit. Now the BGN is on my screen again, right above the zeros. Okay, so let's try this. We have 8 IY. We have second PMT, second PY. And now that we're in the payments per year and the compounding per year, we're going to change that to 4 because it's quarterly. So 4, enter. And then we need second, quit. And then we need 40 for our N. We need 500 for our payment. We need 0 future value. And we need compute present value. And that's going to give us an answer of $14,084.72. So make sure you're able to do those calculations before moving on. And if you have any questions about it, please let me know. Okay. So book value of a lease. The reason for this example is that a lease is always paid in the future, or sorry, at the beginning. So there's always a lease payment the day the lease starts. So this is a prime example of what you use the beginning function for. Please let me know if you have any questions. Thanks, everyone.